Good morning, everyone. Today we're going to start our next unit, which is going to be on area, surface area, and volume. So today's notes are going to be pretty simple, something that you guys have already done many times before. There's probably only going to be one thing on here that is new that you have not seen before. So this is just a screenshot from your formula chart. It's got the formulas for circumference of a circle should you ever need that, and then it's got the area formulas here. Okay, so triangle, rectangle, or parallelogram, so on and so forth. This one is the one that you probably have not seen before, the regular polygon. So basically after any four-sided shape, so if it has 5 sides or 6 or so on and so forth, okay, here is the formula for the area of that kind of shape. It is 1/2 lowercase times lowercase a times capital P. Okay, now this down here has what everything stands for. If I go and find that lowercase a, it stands for the apothem, and I'll show y'all in a second what that means, but that's probably new, apothem. And then capital P is just the perimeter of the shape, so y'all can figure that out. But apothem, we will talk about what that looks like down in the pictures here, okay? So what we're gonna do is we're going to look at each shape and its formula, and we're just gonna kind of draw on here or label what each part is, okay? So in my triangle, the formula for the area of a triangle is 1/2 base times height, okay? So I'm assuming that most of us already remember this, but the base of your triangle has to be all the way across the bottom of whatever that is. So I'm going to kind of show that like this. So all the way across the bottom, that's the base, okay? And then the height is not one of these diagonal sides. It's from the tip of your triangle down to the base. All right, next we have the rectangle or parallelogram. Both of those formulas is base times height. In a rectangle, this is very easy. Base is the bottom, height is the height, okay? Now, in a parallelogram, this does get confused sometimes. The base is still all the way across the bottom, but the height has to be the distance from one, basically the top to the bottom here, okay? So it's not the diagonal side, it's that straight vertical distance between the top and the bottom, okay? Moving on to trapezoid, the area equals 1/2 parentheses B1 plus B2 times H. So B1 and B2 are going to be the top and the bottom of your trapezoid. Okay, and those don't matter. You could switch them if you wanted to. All right, and then height, similar to parallelogram, it has to be that vertical distance between the two bases. Okay, so it's not the diagonal part, it's that vertical distance between B1 and B2. All right, rhombus and kite. I know this got cut off a little bit, but this should be 1/2 D1, D2 for both of those. Okay, so what that's gonna look like is D1 and D2 are your diagonals. So from this vertex to that one, and then from here to here, this is kind of hard to label. Let's go like this. So this one, D1, this one, D2. Again, those don't matter. You could switch them if you wanted to. And then same thing for your kite, from one vertex all the way across to the other, and then same thing over here. This part could be D1, and then this part could be D2, or you can flip them. Okay, next one is, this is a hexagon, okay, but this is the formula. Again, sorry, this got cut off, so this should be 1/2. This is the formula for a regular polygon. Again, 5 sides, 6 sides, anything from 5 and up. We can use this as long as it is a regular polygon, okay? And then regular, all that means is that all these sides are the same. So it's not just like a random 6-sided shape. It's an actual hexagon where all the sides are the same, okay? So what the heck is that apothem, all right? Basically what it is it's kind of like the radius of your polygon. So it's gonna start in the center, and it's gonna go to one of the sides of your polygon, okay? So it doesn't go to the corner or the vertex, it goes to one of the sides, and it always makes a right angle there. So this right here is our apothem, okay? And then obviously P, we know, is the perimeter. So whatever your side length is, you would just add that up with however many sides you have, okay? And then lastly, our circle area equals pi r squared. The only thing that we have in here is the radius from the center to my edge of the circle. All right, here are our 4 examples that we will go through. So the first one, we have a triangle with several different measurements, okay? So the first thing that I'm gonna do, look back at my formula chart and make sure I'm using the correct formula. So for a triangle, the formula is 1/2 base times height. Okay, now we've got a couple different measurements in here. We need to make sure we're choosing the right ones. So the base of my triangle is this bottom part right here, okay? I know that we've got this dashed triangle outside, but the actual length of the base of my triangle is 14, okay? So I'm gonna plug that in for my base, all right? And then the height of my triangle, remember this has to be from the tip of your triangle down to the bottom. It is perfectly fine if it goes outside of your triangle. We just need to know how tall is this triangle, all right? So this 20 feet right here, that's kind of like there to confuse you. You do not need that information at all. So this should be 1/2 times 14 times 12. And then all you have to do from there is just plug it into your calculator and we'll get our answer. So this area of this triangle is going to be 84. And then our units are in feet. Area is squared, units squared always. Okay, number 2, we have a rhombus or a kite. I'm not sure because I don't know anything about the sides, but I do have both of the diagonals drawn in there. So that should help me to realize that I am using the formula for rhombus or kite, which is 1/2 d1 d2, okay? And then the info that we are given is that LP is 2 centimeters and MP is 5, okay? So they have not given us the full diagonal. You need to make sure you pay attention to that. Let's say I'm making this shorter one my D2, okay? If LP is 2, then that means that this diagonal has to be 4 because I need both sides of that diagonal, okay? So 1/2 times 4 for the whole diagonal, and then same thing for this diagonal. If half fits 5, so is the other half, so it'll be 1/2 times 4 times 10. All right, and that ends up being 20. Our units are centimeters squared. All right, moving on to number 3, we have an octagon here. It's got 8 sides, and then again, this part right here kind of looks like the radius of my polygon, okay? Remember, that is your apothem, okay? So the formula for our octagon, which is a regular polygon, is 1/2 AP, all right? So that apothem right there is 12.1. I'm gonna plug that in for my apothem, for my A. All right, and then the perimeter, I know that each side is 10, and I've got 8 sides all the way around. So the perimeter of this shape is going to be 80, okay? And then again, we just plug that into our calculator and we get 484. So 484 centimeters squared. All right, and then our last one is a circle. We have the diameter here is 14 centimeters, okay? Now, my formula for area of a circle is pi r squared. So I need to plug in the radius from the center just to the edge. That would end up being 7 instead of 14. So again, just make sure you're using the right number, all right? So when I plug that in, pi times 7 squared, the first part of this question is asking for the exact area in terms of pi. So all I need to do is just do this part right here. 7 squared is going to give me 49. And then don't forget about the pi. So first part would be 49 pi. This is centimeters squared. And then the approximate area rounded to the hundredths place, I'm just going to plug that whole thing into my calculator, either this one or this one, it doesn't matter. So pi times 7 squared, or 49 pi, is going to give me about 153.938. So that 8, we need to look at the thousandths place, is going to make this round up to 153.94 centimeters squared. All right, and that's basic area. I know that you guys have done this before, so you should be great for your assignment this week. As always, email me or let me know through Google Classroom if you have any questions.